Number 20, what two beta keto esters are formed in the Deichmann reaction of the following diester? Well, remember that is an intramolecular reaction and it is a ring closing reaction. Here we have two alpha carbons. I will highlight them different colors so that we can follow them a little bit. Now, if my carbonyl is going to attach to the blue carbon, then what I will end up with is a 5-membered ring. Here's my carbonyl, here's my alpha, like this. So this is if we attach to the blue alpha. Now, if I'm going to go with the yellow alpha, then the yellow alpha is going to attach to the carbonyl. And when I have that, then I have a product that looks like this. This is a 5-membered ring, carbonyl on it, 2 methyl groups. So that is if we attach to the yellow alpha. And this is blue. Number 21, which of the following compounds can serve as Michael acceptors? Well, remember, a Michael acceptor is an alpha beta unsaturated carbonyl. So here's my carbonyl, here's alpha and beta, so this is a yes. Here's alpha and beta, so this is a no. My alpha and no. And here we have an alpha and a beta, so this is a yes. Number 22, what product is formed when each pair of compounds is treated with sodium ethanoate in ethanol? Well, it might be easier for us to see this if I draw it with this product over here. So this is how I'm going to do this. Now we're going to be looking at this as our alpha carbon. So the unsaturation point here, my pi bond, think of that as flipping out and making a new bond here. So we have this as our product. Let's see if I draw this up this way. So we retain this ester, but now I need to make this new bond. So this would be my product. What I'm doing is I'm looking for the alpha next to the carbonyl, and then the unsaturated carbon, the primary unsaturated carbon, will then attach. So that's the beta carbon. It just happens to be primary. Here's my beta. So in B, I'm looking for something similar. Here's my beta carbon. On my unsaturated, it's an alpha beta unsaturated, and I'm going to draw this reactant out. Let's change colors so we can keep things separate. So we have this, and here we're going to attach this alpha carbon to here. So if I just draw it here, then you get an idea of what this is going to be. We hydrate this, so there is no double bond. So I drew it out here just to be as clear as I possibly can. Now for C, again, we're looking for that beta carbon of that alpha beta unsaturated. So here's that beta carbon. That beta carbon is going to attach at the alpha, in this case, to, let's change colors, to the cyanonitrile here, the cyano group. So those two carbons are going to attach, and when they do, so here's my CH, it was a CH2, and then it's going to attach to that CH, it was a 2. I'm going to put the cyano group up here, my carbonyl down here. Make sure everybody's octet is satisfied. This needs to be a CH2, and that should be what our product looks like. Number 23, what starting materials are needed to prepare each compound by the Michael reaction? Remember, we're looking for an alpha-beta unsaturated compound. From this carbonyl, we have an alpha and a beta. So we can make that a saturated or an unsaturated compound like that. And then, let's erase that. The remainder, come on, pen. The remainder of my compound. Now here, again, we're looking for an alpha and a beta. You could also go alpha and beta this way. That looks like more fun for me, so I'm going to do it that way. Let's see, we need a 5-membered ring. Alpha beta unsaturation and the remaining ketone.